Alright, now we talk about ammeters, and the DC ammeters that I can change the dial to different current range. In this diagram here, you notice the differences now. Voltmeter was the resistor were all in series with my permanent magnet coil moving meters, right? But for ammeter, the resistor is parallel to the meters, parallel. That means to say now if my dial is selected to the 1 ampere range, meaning that I'm measuring the maximum current is 1 ampere. Alright? That means to say if my current source come out, the current maximum that I can measure is 1 ampere. Okay? And if I turn the dial to here, means I can measure up to 5 ampere. And if I turn it to here, I can measure up to 10 ampere. Now, in order to understand the mathematics, in order to be able to understand the mathematics of this circuit, first of all, we must come to the understanding of Kirchhoff's current law. Now, if I have a circuit like this, okay, if I say that this current here is equal to 1 milliampere, right, and my total current here is 8 milliampere, 8 milliampere. Do you know how much is this current? It is 7 milliampere, because 8 minus 1 is equal to 7. 8 minus 1 is equal to 7. That's called Kirchhoff's current law, KCL. Okay? And because these two circuits are parallel, if I call this Rx and Ry, the two voltages here are the same. Because parallel circuit, the voltage is the same. So therefore, I will say 1 milliamp I times R, 1 milliamp multiply Rx is the same as 7 milliamp multiply Ry, right? I times R, both must be the same because they are parallel circuit. Okay? So if you understand this concept, then we can move on to explain the multi-range ammeter circuit. Got it? Let me repeat. When we analyzing this multi-range ammeter concept, the first thing you must know is your Kirchhoff's current law. Yeah? If I have two parallel branches, if I say here is 100 milliamp and here is 1 milliamp, how much is this current? 100 minus 1, so it's 999 milliamp. Okay? And if these two resistors is called Rx and Ry, the voltage across Rx and Ry are the same because they are parallel. So 1 milliamp multiply Rx is equal to 999 milliamp multiply Ry. Got it? Okay, so with that, we can move on to our circuit here. So now let's come back to here that I'm measuring a circuit with 1 ampere. So the current is 1 ampere maximum. And here is the moving coil meter's full scale reflection current is 1 milliamp. So do you know how much is this current now? Of course you do. So let me call this current I call it Ix. Right? So Ix is equal to 1 ampere minus 1 milliampere. Okay? And that is equal to 1000 milliampere minus 1 milliampere. So that's 999 milliampere. Got it? Okay. Now, the voltage, this is a parallel circuit here. So I times R should be the same as I times the 3R. Right? Because these are 3 resistors. Ix will pass through this 3 and come down. Right? So, 1 milliamp multiply the 50 ohm should be equal to 999 milliamp multiply the 3 resistor RC plus RB plus RA. Okay, so that's my equation 1. Right? So now let me keep this formula to somewhere else. So I'll put it here. So 1 milliamp times 50 equal to 999 milliamp divided by multiply RC, RB, and RA. Got it? So that's my equation 1. Then I changed my dial to the 5 ampere range now. Okay? When I change my dial to the 5 ampere range, the current split here. So what this current here would be your 1 milliamp, correct? Not because it has to go through here. So it's a 1 milliamp. So now the Ix that I want to call is here. This is the Ix. So what's Ix now? Ix is the 5 ampere minus 1 milliampere. And 5 ampere is 5,000. So it's 4,999 milliampere. Okay? So in terms of the voltage, it should be the voltage across these two resistors is the same as the voltage across these two resistors because these two are now parallel to these two. So 1 milliamp multiply 50 plus RC equal to 4999 milliamp multiply RB and RA. Alright, so that will be my second equation. Let me transfer it up here. So 1 milliamp multiply 50 plus RC equal to 4999 milliamp multiply RB and RA. Right, so that will be my equation 2. Okay, let's move on to my third combination. I'm now turning to 10 ampere down. If I turn it to 10 ampere down, means now the current is 10 ampere. 10 ampere, come here. So what is the current passing through here? It's a 1 milliamp. So here's 1 milliamp. Okay. So here I will then call it the Ix. Right. So the voltage across these three resistors now are in series, right? Parallel to your RA. Okay. So Ix is now equal to 10 ampere minus 1 milliampere. So it's 10,000 minus 1 milliamp. 10,000 milliampere minus 1 milliampere. So that is equal to 9999 milliampere. Okay, so then I use Ohm's law again. Ix multiply RA, right? The voltage across here is the voltage across these three resistors, which is equal to 1 milliamp multiply 50 ohm plus RC plus RB. Okay, and Ix is 9999 milliampere multiply RA equal to 1 milliamp multiply 50 plus RC and RB. Alright, so with that is my third equation. So let me transfer it to here. So it's 1 milliamp multiply 50 plus RB plus RC equal to 9999 milliamp multiply RA. That's equation 3. Now you have three simultaneous equations, equation 1, equation 2, equation 3. Right? So you can use your substitution or elimination that you learn in the mathematics to go and find out the unknown of RA, RB, and RC. This will take a bit of time because it's three equations, so it takes a bit of time for you to find the unknown. Alright, but that is how it goes. Okay, let me revise. This is a multi-range AC emitter, DC emitters. The methods to work on it is to find out when the dial is at this range, here 10 ampere, the amount of current that passing through here is the same as here. So here is 1 milliamp. If it's 1 milliamp, how much is here? Should be the 10 ampere minus 1 milliamp. So that will be this Ix. Right? Then using the concept that the voltage of parallel circuit should be the same, the parallel branches. So what are the two parallel branches here now? Is RC, RB, and Rn. The three of them joined together is parallel to your RA. Right? And then with that, you set up your I times R formula, and then you get your equation, form your simultaneous equation, and solve for the unknown. And be patient, it takes a bit of time. Okay?